Hi everybody, welcome to the Azo Dye Lab at Tacoma Community College. Today I'll walk you through the full process of making an azo dye in lab. Normally in this lab you're assigned one of 6 different pathways. For the sake of simplicity, I chose just one reaction to do on my own. I chose experiment 4. In this reaction we take aniline 2-sulfonic acid, we treat it with hydrochloric acid and sodium nitrite to make a diazonium salt. This highly reactive diazonium salt can then react with an activated aromatic compound, in this case 2-naphthol, to form an azo dye. We'll talk about this mechanism in a lot more detail during lecture. Let's jump into lab and see how this is done. Alright, for the azo dye lab we need to set up 3 different workstations for each of our test tube. On the left, I'm going to have a test tube that's going to be filled with 0.5 milliliter of concentrated hydrochloric acid, and then I'll prepare an ice bath, which is already there. And then for test tube B, I've got a warm water bath ready, and to that I'm going to add a test tube that contains aniline 2-sulfonic acid and sodium carbonate. And then on the right hand side I've got test tube C, which I'm going to add sodium nitrite to. So let's go ahead and measure out each of those reagents. Let's start out by measuring out the 12 molar hydrochloric acid for test tube A. Test tube A needs to have 0.5 gram of 12 molar hydrochloric acid, which is really, 0.5 milliliter of hydrochloric acid, which is hard to measure out, so I'm going to do it by mass instead. I looked up the density of 12 molar hydrochloric acid, and it's about 1.2 grams per milliliter, which means I should measure out approximately 0.6 grams of 12 molar hydrochloric acid. So I'll try to do that carefully and dropwise. So that's pretty good. I overshot a little, but I'm getting about 6.59 grams of 12 molar hydrochloric acid. Again, the density is about 1.2 grams per milliliter. Once I have the hydrochloric acid in my test tube, I'm going to go ahead and put that in an ice bath, and I'm going to label that ice bath test tube A so I don't get things mixed up. The next reagent I want to weigh out is the aniline 2-sulfonic acid. Specifically, I need to measure out 0.49 grams. So I'm going to do this carefully on a piece of weigh paper. Alright, so now I have 0.491 grams of aniline 2-sulfonic acid, and I'll go ahead and add that to my test tube. Next, I want to add 0.13 grams of sodium carbonate. So I'll go ahead and do that on a piece of weigh paper. Alright, so I've got 0.134 grams of sodium carbonate. Now I'll move that back to my test tube B. Alright, so now test tube B has the sodium carbonate and the aniline 2-sulfonic acid in there. The next reagent I need to add is my water. So I'll go ahead and measure out 5 milliliters of water and add that to test tube B. So here I go, I'll dump the 5 milliliters of water into test tube B. And as you can tell, the solution is going to be quite murky. So what we're going to do is we're going to use the hot water bath on the plate in order to get the solution to go clear. So let's go ahead and clamp that into our hot water bath. And I'm just going to let that heat for a while until the entire solution becomes clear rather than cloudy. Alright, for test tube C, what we need to do is we need to add 0.2 grams of sodium nitrite. So we've got some weigh paper on the scale, and I'll measure out 0.2 grams as close as I can. Almost there. Alright, so it looks like I measured out 0.216 grams. I'll go ahead and add that to test tube C. And once I have that added, I'll add another milliliter of water. Alright, so now I've got the 1 milliliter of water and I've got the sodium nitrite in there. So I'll go ahead and put that in a holding beaker. And then what I might also do is get a glass stir rod to help ensure that the solution mixes properly. Alright, that looks pretty good. Alright, now that we've got all three of our test tubes set and ready to go, we want to double check test tube B to make sure that all of the solids are dissolved. So what you can do is you can pull this out of your hot water bath, check it with a stir bar, and what you should look for is a clear solution. So in this case, it's no longer cloudy, it's nice and clear, all of the solids are dissolved. What we want to do after that is we want to get the contents of test tube C, we have over here, and we want to dump the contents of test tube C over to the contents of test tube B. So I'm going to go ahead and move all of this over, and I'm just going to dump test tube C into test tube B. Alright, to ensure that everything transferred over properly, I'm just going to give it a little itty bitty rinse with water and transfer that over one more time. Alright, so now I've got all of the contents of test tube C inside test tube B. And make sure you do this when it's not too hot too. In this case, my warm water bath had already cooled a little, so the solution was cool to the touch. Now that I have the contents of test tube C all the way in test tube A, we want to pour, or sorry, test tube B, we want to pour test tube B into test tube A, which is sitting in our ice bath. So now what I'm going to do is I'm just going to move my stir rod over here. Probably got shaky hands from too much coffee. And we'll dump the contents of B over to test tube A, and we're going to stick that in an ice bath for about 5 or 10 minutes. What we're looking for is for solid product to start to precipitate. I'll show you a trick though in a second if no precipitation occurs. While I'm waiting for that precipitation reaction to occur, one thing I can do is prepare my round bottom flask for the next step. So what I did was I got a beaker of ice water, and then from my organic chemistry kit, I got my 25 milliliter round bottom flask. So what I want to do next is I want to add 0.38 grams of 2-naphthol to this round bottom flask, followed by 2 milliliters of 2.5 molar sodium hydroxide. So let's go ahead and measure out the next reagents on the scale and then add them to this round bottom flask. So I've got the scale ready. Next thing I'm going to do is I'm going to add my 0.38 grams of 2-naphthol. Alright, so I've got 0.388 grams of 2-naphthalene measured out, and I'm going to go ahead and add that to my round bottom flask. Now that I have that added to my round bottom flask, I'm going to add 2.5 milliliters of 2 molar sodium hydroxide. Sorry, I misspoke earlier. We're actually adding 2 milliliters of 2.5 molar sodium hydroxide. So I'll use this volumetric pipette here to measure out the exact amount that I need. So that's 1 milliliter. Alright, now that I've got all of my reagents in there, what I'm going to do is I'm going to grab a stir bar, and then I'll put it on my stir plate to ensure that everything is mixed evenly. Alright, now that I've got my stir bar, I'll toss that in. I'll kind of give it a quick swirl by hand, and then I'm going to put it on the stir plate. It's okay if it doesn't stand up perfectly. I'm just going to trust that this little beaker holds everything upright because I can't get my clamp to clamp the neck of the flask while it's in this ice bath. So there we go. I've got my round bottom flask stirring with my reagents. I'm still waiting on the precipitation in test tube A to finalize, so I'll just give this a few minutes longer. Alright, so now I'm checking back in on test tube A, which has been precipitating for a while in an ice bath. If you look at it closely, there's some really nice crystals on the inside here. It's a little hard to see with the cell phone camera, so you may have to trust me. But one thing you can do to really encourage crystal formation is you can get a spatula, curve the end, and really kind of scrape up the sidewalls of these test tubes. Sometimes these test tubes are so new and so polished, oh, there we go, that there's really not a good nucleation point for crystals to grow off of. So I'm going to go ahead and kind of scratch this up, don't tell Diane. And then I'm going to put it back into my ice bath for a few more minutes to really see if I can get more crystals to come out of this solution. Alright, so I've let everything sit for a little while longer to see if we could get any more crystals to form. And it looks like we've got a nice layer of crystals at the bottom of test tube A now. So what I want to do is I want to transfer the contents of test tube A all the way over into the beaker that I have on my stir plate that's stirring in the ice bath. And you can see a lot of crystals were left behind, so I'm going to try to agitate them and get them to transfer over as well. If any of the crystals are stuck behind, you can use a small amount of water, not very much, to try to dislodge them and get them to transfer over as well. Just going to do a smidge more. Now we've got everything in my round bottom flask. I'm going to clamp the round bottom flask, and then I'm going to get my heating mantle set up. So I've got my heating mantle right here, got my temperature controller, and I'm going to plug that in. I'm going to heat it to about 3, but in order to prevent anything from boiling up and over, I'm going to use a reflux condenser. In this case, it doesn't really matter if water is flowing through it. I just want to prevent it from boiling up and over and getting into the heating mantle itself and causing the heating mantle any damage. All right, so we'll wait for that to get to a boil. Once it's at a boil, then we'll add our sodium chloride. Alright, so I've been heating this reaction for a while, but if you look really closely at it, it's kind of the solid goo on the inside, so it's really hard to tell if it's boiling. So I'm just going to continue on to the next step, and I'm going to add my pre-weighed portion of sodium chloride. The sodium chloride that I'm adding is going to be 1 gram, and then I'll let it heat for a little bit longer. Alright, so I've got my sodium chloride in there. I'm going to heat that until everything dissolves. Alright, now that it looks like the sodium chloride's dissolved, what I'm going to do is I'm going to remove the heat and let it cool to room temperature for a few minutes, and then we'll put it in an ice bath to encourage precipitate formation. Alright, and as you can probably tell, the solution is this brilliant orange color, so I'm going to let it continue stirring for a while to try to dislodge all of that solid material that's stuck on the glass walls. Alright, so I let my round bottom flask cool to room temperature, and it's been sitting in an ice bath for about the last 15 minutes. The next thing that I want to do is vacuum filter all of the solid product on the inside of my round bottom flask. So I've got my filtration set up. I'm going to turn on the vacuum. I'm going to pre-wet my filter paper. That ensures that I have a nice tight seal. Then I'm going to grab my round bottom flask out of my ice bath, and I'm just going to try to dump everything out of there as quickly as possible. And I'll use a little bit of my water from underneath my hood to help transfer all of my product. Alright, so that looks pretty good. I'm going to let it air dry for a couple of minutes, and then we can take a look at what color the crystals are that we made for our Azo dye. Alright, so I've let this vacuum filter for a while to let it air dry a bit more. Now let's take a look at our solid Azo dye product. Alright, so if we look down in here, you can see that the Azo dye is this sparkly orange color, which is kind of cool. The filtrate, if we look at that a bit more closely, is more of a dark red orange and more or less the same color. So what I'm going to do is get my personal beaker out, and I'm going to scrape the filter paper on the inside and let it air dry for a few more days, and then I'll come in and get the mass for the product later on. Try to get all of the solids out as well, at least as much as is reasonable. That way I don't lose any of my mass. And then we can calculate the percent yield once everything's nice and dry. Alright, so that's it, and I'll see you next week with the next lab.